Ladies and gentlemen, welcome back. So last time we came up with a strategy for the new Trainyard circuitry because this isn't quite working as I want. It's close, but it's not quite right. And for the new circuitry, we said that we would need stations that, we would need stations that send their delta in demand in 1-tick signals, and we need the Trainyards to to modify that memory depending on the trains that they dispatch. The first thing I need to do is figure out how to build a transmitter that sends 1-tick at a time with the correct number. So a variable number that has to be the difference from the previous frame. So we get on that as I always do in my laboratory of sorts over here. Let's see. So falling edge detector is pretty simple. And so is a rising edge. Actually, I think I have some saved. Edge detector, rising, and falling. Falling. Yep. And the other ones. Rising, falling, both. Okay. So this is the one that has both. This is rising edge and this falling edge detector. Now the difference is basically only this one, right? So the rising edge detector detects for those that are positive. This one detects for the edges that are negative, so where the value falls. And this one detects both. So if I show you how that works exactly. You can just look at these. Yeah. So I'm turning this off. And I'm turning it on with a tick delay with fast time. So it's turned on. In the next tick, we get the input here and here, right? As well as obviously over here everywhere. The second tick lets these guys compute what's happening. And they are all times -1, right? So they negate the signal that comes in here. And in the next tick, by the way, over here you can see these guys are outputting the previous signal because it wasn't 0 and it was greater than 0. So in this case, 01 is, or 01 is greater than 0 because it has a value of 1, therefore it gets put through. The same is true over here, but not here. because it's greater than 0, right? Not smaller. And one more tick, and there you can see these guys are now sending their output to these. One more tick. Oh no, this is normal. Of course, these are not waiting for anything. They're just going to constantly trigger this as long as the combinator is on. Now, if I pause time again and I turn this off, the signal has disappeared. We call this a falling edge. You can see here, the signal from here is still there for one more tick, right? So here, the signal, the input has disappeared. We are only seeing the output. In the next tick, that will disappear too. But here we see there's an input of -1, which is less than 0, and over here it's the same, right? It's not 0. And you can see here output 0 -1, but not here because it's a negative number, right? Not big greater than 0. And if I go one more tick, it disappears. Because of course the signal here has disappeared. This guy doesn't have anything to work with anymore. So this is a falling edge detector. And this one, because it goes both into the positive and the negative, is a rising and falling edge detector. And this one's just a rising edge detector. And there you go. Nothing happened. That's basically how these guys work. Now I need to use this guy, because I need to both track when a number goes up as well goes down. And we're going to do that by, don't pause time, there you go. Instead of using a constant combinator, we're going to set up a switch. Actually, this could as well be this. Each plus 0 is a signal. This guy needs to read hand contents. Stack size of 1. And we need a pulse, that's correct. There. This is now a memory cell, so it basically takes whatever it gets and passes it on. Now, if you'll notice what happens, right, it passes it on. Oops, if I do that again, it just saves the memory because it keeps passing on the 03 in this case. It just keeps passing it on to itself via this loop over here with this wire, right? To delete that, I need to get rid of this, and the memory is deleted. Now I'm going to go one further, actually break this connection. So this one is times -1. This one does the same in negative, and this one does it in positive. And I'm going to not feed this off the same. I set a second switch, which does exactly the same as the first one. Whoops. So this one does positive. She simply adds what comes, and this one deletes one, right? I'm actually going to need one more space between the two. Otherwise this happens. Okay. So we now have a system that I can use to shift. I can basically pretend that this is and let's actually use an actual thing I use here. An actual visual signal that I use in the stations. In this case for the loading. I can use these guys to simulate actual changing conditions in stations. So the number of trains say that the station could serve. Okay. You work if anything is not 0. Yep. And you show me doesn't work. L. Yep. Now I need to. This is fine. This can stay just like that. Whoops. This is simply a tick that tells me what's happening. But over here, I want a memory that saves the last. Actually, let's go down for that. My memory cells. These are the big. I don't need those. So you're going to read me. Actually, I shouldn't need more than 99 digits for that. So the red wire is the set. The red wire is the address. Green wire is the info. Green wire goes in over here. The red wire, what do I do with this? I think let's see. So this should do nothing. Indeed it doesn't. Yep. What happens if I use the same signal that I also used? That'll be interesting. I think it might break the memory though. Because of this guy. Okay. Input L-1. Let's take a quick look at the normal memory cell. It's exactly the other way around, huh? That's interesting. Yeah, no, it doesn't work anymore. Okay. That's what I thought would happen. So we add one to the memory. Take outputs. Oh, well, I'm dumb, aren't I? Yeah, same as before. Basically, what I've built here is another edge detector between these two, right? That's why you can't use the same signal as a set signal. So memory set means the signal that tells the memory that it needs to now save what's on the data in. And you can't use the same signal for the set signal as for the data signal. So we'll revert this to an S for set. Because basically putting the same signal as the data signal simply means that you save the reverse of the data signal. Yep. As expected, this is doing nothing. Basically what's happening now is I'm simply passing through the information here because I have no S applied, which tells this circuit effectively to, oh, what happens if I revert this? S is 0. No, this is working. And this is working too. This is basically now doing the exact same thing as this over here. So I don't really need that complicated of a memory cell. Okay. So you might of course think that right now this one is superfluous because I already have the same memory up here. The difference between these two is that the reason it seems that way is because these are essentially already one-tick signals, right? Now what would happen is normally that this entire thing would be replaced with the steady signal from the circuitry that determines how many trains the station can serve, right? So normally I wouldn't have a memory here. Instead, I just have like a constant signal coming in that tells me 14 trains can be served or whatever. And this one would detect any change in that signal and save that change in here. Now what happens if I do +5, right? There you go, it's saved. Okay. So this circuit can definitely deliver the difference. So if you imagine this memory is now the one in my Trainyard, right? This is the final step in my delivery of signals I need to add to this the stuff over here. So let's see which way around did I do it again. Don't need you anymore. And you can come a little bit closer. Yep. Of course I'll have to build the trains again, but whatever. So this one sends an L and this one, wait, this one sends an L. Wait, I'm stupid. I changed that to work in here, right? So unloads are the ones from the high bits and loads are from the low bits, and I can tell that. Let's see if this looks a little bit nicer, maybe. What the hell? Oh. Why is it not? Can you turn, please? Oh. That's a change, I guess. Oh well. Okay. So this should be 3 trains for L. Yep. Loading is L. That is correct. Okay. Just gotta make sure I remember correctly. Where was I? Right, I need to work out the circuitry for delivery, and now I remember what I wanted. So loading stations are not the ones that bit shift, but unloading stations do bit shift. So let's do the simple one first. This way. So I get an L. I get an L, which is the number of trains the station could serve. That's this one. Yes. Okay. This thing is simply a gatekeeper on whether or not the station is allowed to send signals, which almost always it will be, but if there's something that's kaput, do I actually really need that? Do I just cut the... I leave it in. Who knows? It might be useful. And removing it doesn't really get me anything. Okay. So the L is passed through. This is then the delivery in the end. This is the item. This gives me the information of what item it'll be. And here is where I need the falling edge detector. In this case we're on the red wire. On the green wire. We can do that quite simply like this. Remove that wire, replace it with the red wire. So here we have our falling edge detector. Feed that through. And let's see what happens here. It's -5. Oh no. This doesn't quite work the way I meant it to work just there. Instead of feeding in here, we first need to actually feed in here. There you go. This goes in here. we go. But then weird. Okay. Pass through here. This. Yep. Hmm? I hit the wrong button. Let's check that again. Okay, we're currently in time pause. Why do you not save? Oh, I don't need to connect to this anymore. I need to connect directly to you down here. You are now obsolete. I think down here. Yes. Okay, so oh. Yeah, of course. Why are you not? Okay, that was this. This one shifts by +5. That is not +5. 7 +5. No. Why is it getting 6? Because of this? Maybe. Shouldn't. That shouldn't be the case. Let's see one more time. Currently at 19. Yep. Okay, 19, yes. 19, yes. 6. Something's off there. Okay, first of all, let's delete all the memories for a moment. Okay, pause time. Twist you once. Hey. Oh, plus, of course. I'm stupid. But time to delete. Five, 0. So far, so good. Okay, I think it's working as intended. Okay. No. Should be at a 20. We are. And I actually want... Except this is an L. Okay. So you need to bit shift. And because you need to bit shift, I'm giving you extra. I think I've already deleted them, haven't I? Five is more than enough. Okay. Let's see how that works. Yep, works just fine. So in here we need to bit shift. Up here I did that just before the final check. But I really don't have to. I think I can fit that in after this just fine. Was there any space? Yep. I think I'd still prefer to do it like this. Yeah, that actually, yep, that is correct. 655360 should be exactly a bit shift of 16 to the left. You can check that real quick though. Yep, 65536. There is a 0 too many though. What? Oh, because it's a 10. That works. Yeah, it's correct. Okay. Let's try with a 1. Indeed. It's looking good. I can basically add these on top of each other now without problem. And drive the memory is insane. There you go. And with the right decoder, it's this thing over here. Three and 3. Let me delete the memory real quick up here. I should have one load and one unload now. 1 and 1. 2 and 2. 3 and 3. Yep. So if you're wondering what I'm doing here, I'm basically testing whether or not the system is working as I am imagining, except of course what I need to fix is this is not connected directly instead. Yeah, no, this is correct actually. Yep. This is correct. This is connected to the trains. And down here I have the Trainyard. The Trainyard will pass back up with or without a bit shift, depending on what it is. What kind of train I have dispatched to subtract that from the memory. Okay, so this is essentially most of the circuitry done. I just need to transfer it over and make sure that the tick delays aren't breaking it. because as you might imagine, if I have multiple trains going, the dispatch signal might actually refresh upwards faster than the trains can actually remove themselves from the global memory. So that's a problem that I'm going to have to work out, I think. But that's for the next episode. Thank you for watching.